Alright guys, I'm going to recap some of the vocabulary from this section about electron configuration, and then I'll walk you through some examples. So remember, electron configuration is just simply what's going to tell us how these electrons are going to fill their orbitals. So an orbital is just the space that two electrons can be held. So when we're drawing it, it's like the box. Remember when we were looking at, say, the p orbital had 3 boxes for electrons to fit in. And the s orbital had 1 box, and so on and so forth. Think back to the house, or the boarding house, and the sunny room only had 1 bunk bed, and the pink room had 3 bunk beds. So the orbital is like the bunk bed, or the box. Now the shell is like the coefficient that's before it, so if it's like 2p or 1p, or whatever this coefficient is, that is what the shell is. So when we were doing the boarding house example, that was like the floor. So the first floor, the second floor. Now the subshell is the letter within the shell. So that would be like the S, the P, and the D, and the F. Now some other words that we will be using are N, the principal quantum number. We haven't talked too much about it. Basically, I mentioned it briefly the last day of lecture, but then I've been gone since. So the principal quantum number is essentially how far away these electrons are going to get from the atom, or how large the atom really is. So if you have, say, n equals 1, those electrons are really close to the nucleus. And if you have n equals 6, it's really far away. So some examples would be like the 1s, 2s, 3s, 4s, 5s, 6s, 7s. Each one of these, that coefficient is that principal quantum number, or n. Now, angular momentum, what we sometimes call L, tells you the shape it's going to take. So up till now, we've been thinking about it like an S, a P, a D, and an F. So simply put, I'm going to come down here and draw. An S is going to be spherical. P is like dumbbells. D is typically drawn like a 2-dimensional dumbbell. That got kind of funky. And then the F kind of looks like, if you know what trucker brakes look like, kind of like the pancake brakes, but with some like dumbbell poking out of each side. So these are the L, the angular momentum, what shape that those are going to take. Now, this M sub 1 is going to tell us the quantum number. So it tells you how the orbital is going to be positioned in space. So for instance, the X, Y, or Z coordinates. So X, you guys probably know. Y, you probably know. But Z is like the 3rd-dimensional space that comes like at you and away from you. So those X, Y, and Z, if you visualize these shapes, they can take place on any one of those 3 dimensions. All right, so come down, and next we've got the spin quantum number. And you can either have a positive 1/2 or a negative 1/2. And the way we draw that is, remember when we said, say we have, I should probably draw it over by the s orbital here. In the s orbital, we have 1 box. And in that 1 box, you're going to have 1 electron that spins up and 1 that spins down. That up spin is that positive 1/2, and that down spin is the negative 1/2. And when we're looking at a specific electron configuration, let's say it ended with a D orbital, and D orbitals have 5 boxes, 1, 2, 3, 4, 5. So let's say you had 1, 2, 3, 4, 5 electrons. that would have ended on a positive 1-up spin. So that's what we would say that the spin is the whatever one you end on. But let's say you end up having 6, 7, 5, 6, 7 electrons. So your last electron would have filled with the negative 1/2. So it's whatever you end with is where you're going to get that spin quantum number. Ooh, I randomly deleted stuff. All right. I wanted to delete this bit so it doesn't get too crazy. It's already getting a little crazy. All right, so those are just some words that we sometimes will use when we're talking about electron configuration. So let's jump into actually doing some. So one of the worksheets that I gave you, so this should look at your periodic table, and this is one of the worksheets that I've given you, so I'm going to work through a couple of these. This is a reading that I really liked that I will post for extra reading, for extra assistance where needed. But one thing you need to remember is essentially this. This is what your periodic table should really look like. We've got the hydrogen and helium are in the S block. And then your D block is essentially your transition metals, and your P block is boron to neon, and all of them down. And then F is the lanthanide and actinides. But there's a little bit of tricky jumping. So if you notice, if you look at 4S, where you've got potassium to calcium, when you jump over to the D block, you actually jump into the third energy level, or the third quantum number. So we have to remember, hopefully you've got your periodic tables labeled, that even though this is 1, 2, 3, 4, 5, 6, and 7, this is actually 3, 4, 5, 6. This, however, is still 2, 3, 4, 5, 6, and 7. Okay, and again, let's look back to this chart. So that really explains the D block, but notice the F block, you actually end up filling. So when you go from 58, it would actually fall after 57 here in the D block. So you were at 3, 4, and 5, but actually you're going to jump up to 4. Okay, so then it's 4 and 5 for your energy levels for your D block. So 4 and 5. So again, even though they fell right here, we're actually going to bump them up 1, just like the D block did. Okay, so once you have that labeled, all you need to do is follow your periodic table. It's not very often that I'm going to call out much down here. I mean, there might be a couple examples on your practice worksheet, but there are some things that change based on basically what your teacher wants you to do, so that's why I don't do too much down here. The biggest trick comes in when you're going to 56 to 57. Do you jump down and do row 5, or do you come back? So there's some funny stuff down there. So typically I'm going to stay above this line on your test for sure. Worksheet, you might see some all around. So let's go ahead and try some of these. So your first one is lithium. So if we find lithium on your periodic table, it's going to be number 3 right here. All right, so every single time we are going to start with 1 electron, and we're going to fill from hydrogen to helium, which takes us, I'm going to do this one, 1s2, hydrogen to helium. Okay, so we went here to here. Okay, now after 2, we come down and do 3, which is where lithium is. Lithium is in the energy level 2, the S block. Remember, this is the P, D, and F. So now we are in energy level 2 of the S block with 1 electron filled. Now if you wanted to go a step further and do the orbital filling, typically the way we write it is we would write the electron configuration, and then we would draw our boxes right underneath it. So S is easy because there's only 1 box. When you do P and D and F, it's easier to space your configuration out. So we got 2 electrons and then 1 electron. So that's what your orbital filling diagram would look like for lithium. Now let's look at oxygen. Oxygen is number 8 on the periodic table. So like always, we are going to start, I'm going to change my color for this guy. Hydrogen, helium, so 1s1, 1s2, and then we go 2s1, 2s2. So we filled 1s2 and we filled 2s2. And then we're going to jump over to 2p. Again, we're just following the numbers. We went from 1 to 2 to 3 to 4, 5, 6, 7, 8. So now we are in energy level 2 of the P block, and we go 1, 2, 3, 4 to get to oxygen. So we do 2p4. 2p4. And that is your electron configuration for oxygen. Now again, I'm going to do my orbital filling diagram just below, just for extra practice for you guys to see it. So there's one, and remember P has 3 boxes. So 1, 2, and 3. 1 up, 1 down, 1 up, 1 down, and I've got 4 electrons, so 1, 2, 3, and I come back and do my 4th. All right. So that was for oxygen. Let's move on and do calcium. So calcium on our periodic table. Oh, I'm going to erase some of this so we don't have so much going on. All right, so this time I'm looking at calcium. So find calcium on your periodic table. I'm going to erase this guy. All right. Calcium you will find is over here, number 20 on your periodic table. So again, as always, we're going to start 1s1, 1s2. I filled the first s orbital. 2s1, 2s2. Filled the second. 3s1, 3s2. No, sorry, I should have jumped. I have to go from beryllium over to boron and fill the P. So that would be 2p6. All right, and then I come down to the 3rd level now. I have to fill that 2nd level before I can fill the 3rd. It's the mistake I made there. So I have to come back, and now I'm in 3s, fill both. Then I go over to 3p and fill all 6. Then I come down to the 4th s, 1, 2. So all the way up to 4s2. So it's 1s2, 2s2, 2p6, 3s2. So that was the 1s2, 2s2, 2p6, 3s2. Got that one. Now 3p6. Okay, and now that I filled the 3rd energy level, I can jump down and do the 4th, and I got 4s1 and 2. 4s2, and that takes me to calcium. All right, let's do titanium. Again, I'm going to erase all this. I'll choose a new color here for you guys. So titanium, let's go black with that. So titanium is here, number 22. So we will have everything we had because this is further than calcium. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. All right, but now from calcium we go 3d1 and 2. 3d2. 3d2. All right, I want to take all of that and do a little orbital filling. So I'm going to start with my S. It's 1 up, 1 down, 1 up, 1 down. P is 1, 2, 3, up, 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 down, down, down. Can I get a finer point? Yes. Okay. S goes 1 up, 1 down. P has 3 orbitals. Sorry, I should not call it orbitals. S has 2. D has 5. Remember, we can find that by counting the number of electrons in that D row and dividing by 2. Because every single one of them, oh, this is turning funny colors on me. Every single one of those orbitals are going to have 2 electrons inside. All right, now 3D2. We only have 2 electrons, so it's up and up. There's 2 electrons. That would be the orbital filling diagram for titanium. All right. Let's try rubidium. All right, I'll give you a second to find rubidium. Sometimes that is the trickiest part, finding some of those ones that we don't do so often. All right, I hope you found it too, right here. So we are going to start by filling everything we've done before. This is even further down the line here. So we're going to do 1s2, 2s2, 2p6, 3s2. I like to visualize the periodic table as I'm going through here. 4s2, 3d. D goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3d10. Okay, and then I jump over to here, and now I'm in level 4 of the P block. So 4p, 1, 2, 3, 4, 5, 6. So 4p6. All right, once I fill all of that, I'm going to come down to 37, which is my rubidium. And I am in 5s1. 5s1. All right, there's rubidiums. Now, let's do leads. Erase all this while we look for lead here. It's going to be over the metal region, the common metals. All right, so I hope you found lead. It is PB. Some people think peanut butter. Oh, I must have my blinders on because I am not seeing him. It's in this region. There he is. All right. So lead, number 82 in your periodic table. We are going to do a lot of jumping to get to him. So let's fill up to where we did before with the rubidium. So we're going to have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4s, whoa, is that a 5? 4p, is that s? 4p, p is going to have 6. I don't know what that number is supposed to be. And then 5s2. Sometimes it wants to write instead. All right, so I'm at 5s2. Okay, then I'm going to do 4d10. All right, and then I'm at 5p6. Come down to 55, and I'm at 6s2. Now I'm at 5d. See, this is where people go back and forth. So I'm not sure which way the answer key did. Some people will tell you to do 57 and do 5d1. So we would write 5d1. And then they would come down and do 58 through 71, which would be 4f. Oh, geez Louise. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then they would come back up and do 72 and go 9, which would put us still in 5, still in D, and do 9. Okay, but what most people will tend to do is pull this guy over and just do a 5d10 there, which is, if I had to guess what the answer key did, either way is fine with me. Like I said, we will very rarely do all the ones down there. All right, so we'll just keep going as we are here. Come on. Okay, I'll use my finger. So now I am up to 80, and I need to get to 82, so I'm going to do 6p2. And there we are. I'll rewrite this bit here in the middle to show you what the answer key probably did, if I had to guess. Just rewrite it next, it looks messy. Probably did 5d10 and at 14 and SP2. Now again, if you jumped in and did that 5d1, did the 4f and came back, that's fine too, because that's in the order of the logical way we were working here. Okay, should I do erbium? All right. Honestly, I think that should do it. I think we've got lots of examples down here. I'm going to erase my periodic table to make sure that you have got those levels labeled. That way, when you are doing this on your test, you don't have to overthink which hybridization is happening, and that means this bit here and this bit here. It can be on your periodic table. You don't have to memorize that. There is one way that people often do it, and it's this. So essentially, if you were to look starting at hydrogen, you will have 1s, and then you go 2, 3, 4, 5, 6, 7. Oops. Okay, and then you go, I wonder if I can copy it over. Okay, and then you do P, but you jump down 1, and D, you jump down 1, and F, you jump down 1. So essentially, let's see if it lets me paste this guy in here. Move, move, move. That probably won't me. All right. All right, I'll finally quit trying. All right, so I will just do it. So you're going to write 1s, 2s, 3s, 4s, 5s, 6s, and 7s. Okay, and again, the reason is if you look at the periodic table, that's how many energy levels you have. So 7s, okay, and then we'll do P, and we'll go 2P, 3P, 4P, 5P, 6P, 7P. Okay, then D will go 3D, 4D, 5D, 6D. I believe we stop at 6D. Personally, I don't like this method because to me it makes sense just to look at the periodic table. But if you didn't have a periodic table, that is the belief behind this one. I will give you a periodic table for your test though. Alright, so now we've got 4F, 5F. Remember, there's only two, the lanthanides and actinides for the F block. The D block only has 4 levels. The P block only has these 6, and the S had 7. Okay, again, those are the energy levels. Now what you do is you draw a line or at an angle through each of them. So I'm going to choose a different color to show you my line. So you're going to fill the 1S first, then you're going to come back through and fill the 2S, then you'll come back and fill the 2P, 3S, and then you'll fill the 3P, 4S, 3D, 4P, 5S, 4D, 5P, 6S, 4F, 5D, 6P, 7S, 4F, 6D, 7P. The theory behind this is if you were not given a periodic table and all you could do is remember that the S, P, D, and F blocks went in that order, and this is how many rows they each had, you could figure out the filling order. We can look at an example here. So let's look at, for instance, let's pull silicon for 14. So if we are doing silicon's electron filling, we will do 1s2, 2s2, okay, then we can fill the P, 2P, and P can always hold 6. So I've got 2, 4, and 6. And in theory, we know we got to get to 14 because that is the atomic number. This one, okay. We have to get to 14. I should probably write it where it belongs. Okay, so silicon 14. So 6, 7, 8, 9, 10. So after the P, 2P, then I'm going to fill the 3S. 3S, 2. So I've got 6, 8, 10, 12. I need to get to 14 still. So I've gone so far 1S, and then I did my 2S, and I did 2P and 3S. So now I'm going to go 3P, 3P, but I have 2, 4, 6, and 12 so far, and I only need 14, so there's only going to be 2 in the 3P. So again, that is how this image that you will see is frequently used. Again, that's assuming you don't have a periodic table in front of you. And as review very quickly, I'll draw my orbital diagrams for each of these. This is what we're going to start focusing on next week. So 1s2 means you spin up, spin down. 2s2, 2 electrons, 1 up, 1 down. P will always have the 3 beds. So 1, 2, 3, 4, 5, and 6. S will always have 1 bed. P with 3 beds. Even though there's only 2 electrons, you still draw all 3 beds. Sorry for how messy that is. All right. That's weird. Oh, it's because I'm close to that type box. There we go. All right. Well, that is about it for now. Just wanted to give us a little bit of a recap and some examples here.